I'm not locked in here with you. You're locked in here with me. All right. Thanks for coming. Thanks for turning up. This is sound design with Vierklang. And what I'm going to be talking about today is what kind of environment do you need for meaningful sound design to happen? How does Vierklang work in the first place? And what are some of the more advanced things that you can do with it? And maybe first a couple of words about me, if I get this microphone to cooperate. All right. All right, so some of you know me, some of you may not. My name is Sebastian Grillmeier. I'm from Berlin, I'm local here. I'm a demo scener under the name of Wayfinder in a group called Farbrausch, and we had some nice productions. And I've been a demo scener for about 15 years now. And yeah, I do music, I do also some graphics, some direction. But yeah, today I'm going to be talking about sound design. Sound design is something that I've been doing for maybe 5 to 10 years, using various software synthesizers, and we started using the Farbrausch V2 for a long time. That was the one that was used first in the product, and later in lots of other 64Ks. And now Vierklang is one of my favorite developments in scene synths. It's amazingly versatile and still so small that it's been used for a lot of the very best 4Ks. So what does it mean when I say design setup? I'm talking about the listening environment. You need actually for you know, a room like this, it's got straight walls with very hard surfaces, and sound just bounces around in it, and the waves cancel each other out, or they resonate, and you get a wrong picture of what the sounds actually sound like. So it's good to have a room that will compensate for the way waves work in the real world. So if you can set up a room that has bass canceling and that has audio foam that really swallows all the frequencies that are flying around the room, so you just hear what's coming out of the speakers and not what's coming back from the walls. And then the speakers are very important. Studio monitors are a lot different than hi-fi monitors. So if you have like the little Brüllwürfel for your laptop or something, those are produced to make pop music sound as good as possible, and that's a different application than what you're doing when you're designing sounds in the first place. So what you want is something with linear frequency response, so that there's no attenuation of the bass and no attenuation of the treble, and that it's just every frequency comes out of the monitor in the loudness that it originates within the synthesizer. And I can recommend you know, really shopping around for monitors if you don't already have good ones. It's really important to get this right. You need to be comfortable with the speakers, but you also need to be comfortable with the budget, which is always a concern. But this is an investment. I've had my monitors for, I think, 13 years now, or 14 years, and they were very expensive when I bought them, and it was an investment, but it was worth it. And I can only recommend going to the shop of your choice and testing out as many pairs as you can, both with your own music and with reference tracks from other people that are mixed well. I took a couple of noisier tracks and some trance that I liked, and just stuff that I knew was well produced. I think I brought the Black Album from Metallica as well, just to get an impression of how different styles of music would sound on these systems. And then I narrowed it down to 2, and it ultimately came down to the loudness. And it turned out that some monitors don't develop their best sound until a certain threshold of loudness has been achieved. And in consideration for my neighbors, I chose the ones that were sounding good even at a lower volume. And that's how I ended up with a pair of monitors by the Finnish company Genelec, which are really nice, and I cannot recommend them enough, but they were pretty expensive. All right, so what to do if you need to make music and you don't have monitors? If you, for example, are on the road somewhere, or if you're making music at night when you can't even use the monitors that sound good at lower volumes, headphones are also a good alternative, and they're also important for certain tasks in mixing. You can probably do a better stereo image when you're using headphones than when you're using monitors, and it's also just as important to shop around for good headphones as it is for good monitors. I ended up with 2 different pairs, one from Sennheiser, which were kind of half hi-fi, half studio monitor. They're half open, which is good for the sound, and it means that some of the sound will come out of the headphones. So if somebody else is in the room with you, they'll hear what you're doing, and it'll drive them nuts. So I also got, for situations when somebody else is in the room with me, I got a pair of closed headphones, and I'm using Audio-Technica ATH-50s, which are very nice at a very affordable price. And those also shield me from outside noise, which the Sennheisers don't. All right, so once you have your physical setup already, the next thing you need to do is you need to know what you're doing when you're designing sounds. So you need to step up your analytics game if you don't already have that. I'm using spectrum analyzers, signal analyzers, and an oscilloscope, which is actually the same as the signal analyzer, just in the different with different timing. So what the signal analyzer does, that's the white one in the lower left. That gives me a real-time view of the wave that's currently playing, and it's synchronized to zero crossings, so that I'm going to show you later what that means. So I'll always get a static image of what the wave is currently looking like, what a short loop of the wave is currently looking like, and the oscilloscope is basically the same thing, but it's slower and it's continually updated. So it gives me a view of what it would look like in a wave editor, basically. And the spectrum analyzer, that's the one in the top right, that gives me an overview of which frequencies are how loud compared to each other. In the image there, we have something in the low mids, or in the lows, which is this peak. And if depending on what kind of plugin you use, this is a free one. It's called Voxengo Span. It can tell you all kinds of things about the frequencies, what nodes these are, and how loud exactly they are, and so on and so forth. You need some time? All right. So this is what I am using when I'm designing sounds to get an insight into what I'm doing, to be aware of what I'm doing, and not just click around until I find something that sounds good, which is also valid, and I'm gonna go into that later. But I like to still know what it is that I'm clicking around on. All right, let's talk about Vierklang now. The Vierklang basics. So how it works is you have a single Vierklang plugin, and there's a footnote there. I've been talking to Gopher, the author of Vierklang, and he's going to release the new version on Monday, I think, which I'm already using for this talk already. And there's going to be Achtklang, which is a second plugin that can run in parallel with Vierklang, so you can have more channels. And there are some more amazing changes in Vierklang as well. You'll have, I'm going to talk about it later. So what happens then is you send note data on different MIDI channels to the plugin, and that gets turned into sound there. You have only one instance of the plugin, and all the note data from the MIDI channels you can route as you wish, depending on your host. I'm using Ableton Live. I can just set it up in the track. I have a track target for the MIDI data. And Vierklang basically throws away all the MIDI data except for the notes and the note offs. There's no volume. There's no aftertouch. MIDI CCs are ignored, so you don't have a lot of modulation options from the controlling MIDI. But there are other things that you can do, and I'm going to go into that later as well. All right, so this is what the interface looks like, and this is already version 3.11. The currently released version is 3.01. So I'm just going to go quickly over the different areas of the interface and highlight the changes that were made since the last version. So at the top here we have the file operations. Patches are sets of 16 instruments that are assigned to the 16 MIDI channels, and you can load and save instruments, single instruments or patches, and you can also reset them to the standard, which is depicted here. This is called the stack, and I'm going to explain more about it in a second. This is where the magic happens. This is where you do the modular synthesis that Vierklang uses. And then you have here in this area, you can set options for the operators that you add here. And then you have instrument properties, which is pretty much self-explanatory, except maybe for the last one, which is new, that this wasn't in the currently released version of Vierklang. You can link voices now. There's another thing you need to know about Vierklang. It's not polyphonic, so every channel only can play one note at a time. So what you do if you need to make chords is you have two instruments with the same settings and you send different notes to them. And now you can link those, and if you change something in one instrument, it changes in the other as well. All right, and then we have the export, and I'm not going to talk about this at all because this is coder stuff and I don't want to go near it. I've had to, and it wasn't fun. And then at the bottom here we have global options. There is a polyphony actually, but it's a hack, and what it does is it screws up everything. No, it actually works to smooth out some of the clicks that can happen. But it's a hack, and the things that it does behind the scenes interfere with some of the more esoteric options. And so I usually leave it at single polyphony. And it doesn't really, even if you set it to 2 times, you don't really have 2 notes that are playing at once. You just have one note that starts while the last note still fades out. So it's not really that you can play intervals. You can just have smoother transitions between nodes. This is an important checkbox always on top. Vierklang captures keyboard events, so if you're playing with your keyboard in Renoise or in Live or wherever, and you're using your computer keyboard to input notes, you always have to go to the sequencer, click that, let that have focus before you can use that, and then the Vierklang window disappears and you can't see what you're doing. So it's good to have that separate window always on top. And there's a panic button, and I think you can all guess what it does. It gives everybody panic. All right, I promised I was going to talk more about the stack. If you're a programmer, you know what a stack is. It's a stack. You know, you stack things. You have a set of things, and you layer them top to bottom, bottom to top. And the thing that's on top, you can work with that, and the things that are below that, you usually don't have direct access to. And this is similar in Vierklang, and I'm going to show you what I mean with this is the default patch, and I'm going to show you with that what it means, the stack. So we have first an envelope, and this is a standard attack, decay, sustain, release. And it looks like you see there in the corner here, and this is the first item on the stack, and then, and then if we add an oscillator, then that gets added on top of the envelope in the stack. So we have a stack made up of the envelope at the bottom. And above that, on top of that, the sine wave from the oscillator. Now the next op that we use combines these two. It's an arithmetic. I don't know. There are different ways to pronounce that. An arithmetic op that multiplies these two and creates a new wave that multiplies the values here. You can see the orange line is the 0 line, so the envelope starts at 0, goes to 1, goes back to the sustain level, and then goes back to 0 when you release. And the sine wave oscillates between +1 and -1. So if you multiply those, what you get is this. And we also pop. Popping means you remove the top element from the stack. So we multiplied the sine wave onto the envelope. We got this shape, and we removed the top element, and now there's just one element on the stack, which is this wave. And then the next thing we do is we use a panning op. I'm omitting the delay line because it overly complicates and it's not necessary. So the next thing is the panning operator, and what that does, it just creates a second copy of what's currently the top element on the stack, and it according to where you pan it, it changes the volume of the two. I'm just leaving this at 0, so they're equal volume. And then the last step is output. What the output does is it checks that there are exactly 2 elements on the stack, and it creates a stereo waveform with one as left channel and the other as right channel. I think the bottom one is the right channel. I'm not quite sure actually. So if we test that, this is what it actually looks in the oscilloscope, and that's pretty much what we predicted from how it works. All right, so let's get into some Vierklang Fu. And I'm going to show you a bit more about how to use the elements in more creative ways than just the standard patch. And what we're going to use there is one more tool, and that tool is a well, it's a way to see what's currently on top of the stack. There's not really a way to usually do that, but if you store the current value into a new instrument, then you can look at that instrument's output, and you get the top element in the stack in the oscilloscope there, and that's how you can visualize, envelopes and so on, and visually edit what you're doing there. All right. I'm going to be trying to do this live, and I noticed when I tested this on the laptop, I noticed that my laptop is not very fast, and Vierklang needs a lot of CPU. This is a 7-year-old computer, basically, so yeah, it might get a little choppy, and I apologize. I'm going to be talking about different ways of sound designing, and the first one I'm going to be talking about is exploration, which is when you're just clicking around and seeing what works. And I'm going to try and just do that live right now. Let me quickly set that up. So this is the default patch, and I'm going to try and just make something worthwhile from it. Let's hear what it sounds like. Okay, that's very silent, almost contemplative. Like a flute or something. Very, very NES. We can take a look at what that looks like as a waveform, and I'm gonna use the spectrum analyzer if I can find it. No, that's the signal analyzer. I'm sorry. So you can't really see what's going on there because it's so silent. So I'm gonna change the view here. All right. I'm sorry that this is such a small window, but it's not resizable, unfortunately. So this is what the wave currently looks like. This is what comes out of the standard. This is what comes out of the standard default instrument when you initialize or reset a patch in Vierklang, and that's not very exciting. So we're gonna do. Let's click around a bit and see what happens. So first of all, I'm just going to remove the delay again because it just complicates things a bit. But yeah, let's perhaps try and make this a bass. And I'm going to use a saw wave here in the oscillator. This is actually a triangle wave right now. We can change that with the color parameter. So if I move this around, you see how the waveform changes, and you can hear how it changes as well. I'm just going to do that without talking over it for a second. All right. And since it's a bass, we're going to transpose it down 1 octave, 12 semitones. Yeah, that's nice. Okay, so we can make it a little louder, I guess. Let me see if I can swing that. Ah, that's better. All right. Deeper notes produce longer waves, so I'm going to zoom out here a little so you can still see what's going on. And it's gone. All right, so what's next? I think we're going to look at the envelope and see if we can make this sound more like a bass in terms of articulation. So it needs to come in faster. Let's say something like this. And now we have something. Let me see if I can find something that will sound like a bass when it's playing. I have prepared something. Let me see if I can find it. That wasn't it? Ah, okay. That's much more professional. Okay, simple bass line, and now we hear that it already sounds a lot like a bass actually, but it's still a bit, weak. And what I'm gonna do is maybe, what do we have here? Distortion sounds good. Just something. Oh, that's a bit much. Just a little distortion. And this is sampling and holding, which otherwise is known as a bit crusher. And you can see it up here in the display what it does. Just makes it more jaggy. Yeah, just a little of that maybe. All right, and then I'm going to shift these around a bit and add a filter. There you go. That's good bass. Actually, what we can do is we can control the filter's cutoff with the same envelope that we're using to modulate the volume. I'm going to try and do that. Let me just let's turn down the resonance by turning up the slider. That's you need to know this. And then we are going to change this frequency through this envelope. And how are we going to do that? It's not going to be with an arithmetic, but it's going to use a store. And I'll show you what that means. So we're making a space here. At this point, at position number 2 in the list, there's the envelope is the top item on the stack, and now I am going to send this value using a store, and I'm going to send it to the filter here. Choosing the filter and cutoff frequency. This is the parameter I'm sending it to. Very 80s. All right. So this is a pretty nice bass already. It's not bad. But we can do more. We can add another oscillator to give it a bit more a bit more punch. And I'm gonna try and do that by, let's see. I'm gonna do that just before I go into the panning. So here comes another oscillator. Oops, now the sound is gone. Why is the sound gone? The sound is gone because at the point of the output there are 3 items on the stack. Because I just added the oscillator, there's a new item on the stack, and now that there are 3, the output won't work. So I need to get rid of that one signal somehow. And what I'm going to do is I'm going to add it to the previous one. So this is done with the arithmetic again. And I'm using plus pop. So what it does is it adds the new oscillator that I just created to the one that was playing earlier, and now we have two voices playing at the same time. Basically, I could make an interval from that. Now, if I go into this oscillator and transpose it to, let's say, a quint, a fifth. Now we have two things playing at the same time, but we want to reinforce the bass, so I'm just gonna go low again. And since we are going to be playing these together, I'm gonna change the phase on this one. I'm gonna be talking about why a little later. And we also want this to be a saw wave. And let's see. later, we're gonna detune later. All right. So, what do we have here? Now, this new oscillator is currently not being modulated by the volume envelope. So I'm gonna move this multiply and pop. I'm gonna move that down after this plus pop, so that the envelope is multiplied with the combined output of the two oscillators and not just on one and then the other one added on top of that without volume modulation. So I'm gonna just move that down here, which is really fucking hard to do from this angle. All right, so now the volume envelope gets applied after the two oscillators have been added, and now I can also go into this oscillator and let's see, what do we have here? The color. Ah, that's better. Woo. Oh, it's maybe a bit too much. All right, that sounds good. Okay. So what else can we do? We could look at this, and this is currently the gain of the second oscillator. We could change that using the same envelope again, so that it has a tighter volume curve. So what we're going to do is move things around a bit here, so that we have more space to put another operator up here. And we're going to use another store and set it to the new oscillator, which is this one, and modulate the gain with it. All right, I think the effect is very subtle. Yeah, probably not really necessary. Okay. What else do we have? We should probably check that there isn't too much low end. So do we have something that can do that? Yes, we have. We have the spectrum analyzer. Let's see what that output says. There's a bit of rumble maybe in the bass. So what we can do is make space here and add a high pass filter. Just a very low one. And because high pass filtering always sounds better with a bit of resonance, we're going to do that. And we can actually attenuate that a little more, even using a peak filter. Those are basically like equalizer spikes. This is peak filter, and I'm gonna use the same setting here, 18 I think it was, as on the other filter. And now we have eliminated any rumble that might have been there, and have a more meaty bass still with this bass note accentuated. All right, so this is pretty nice. Let's see what other modes of working there are. The next thing I want to talk about is, and I'm going to close these here for a second. The next thing I want to talk about is a more directed approach. So if you already know what you want to do, let me just quickly turn that off here. If you already know what you're going to do, and you just need to figure out how to do it, that's working backward in a way. You have a desired outcome, and you need to make sure you get that outcome from Vierklang. And the example that I'm going to use here is a kick drum. I'm going to play you a kick drum that I found, which is it's just a sample from a regular sample pack. And I like that kick drum, and I wanted to recreate it as closely as possible in Vierklang. And I'm not going to show you the whole process of that here today, because it's a little complicated, and there are a lot of steps, and it takes a lot of listening, and it's just not possible to do in this setting. I'm very sorry about that. But I'm going to tell you as much as I can. So let's maybe just quickly listen to the kick that I found that I liked. This is the one. It's a kind of beefy kick. Let me turn it up a little. Okay, that's a good kick. So what I did with that kick was I analyzed the shit out of it, and I tried to recreate it in a plugin called Kick, which is a good name because that's all it does. It's a kick drum synthesizer from Sonic Academy. It's really good. I cannot recommend it enough. It's a really good plugin. And what I did was I found out how to emulate this kick that I found as a sample using only synthesis, using a sine wave with a pitch curve and an amp envelope. So we have one envelope for how high the note that's being played is, and one envelope for how loud it is. And then on top of that, a click, which is the attack for the kick. And what I found out was that this kind of pitch curve sounded a lot like the sampled kick. So how do you recreate this sort of envelope in Vierklang when you only have ADSR controls? And the answer is you use more than just that one envelope. You use several, and you can combine them just like you can combine waveforms with plus and multiply operators. You can combine envelopes as well. So I'm going to try and set up so that you can see what's happening. The tool that I mentioned earlier that shows you the top of the stack. Let me see if I can quickly do that here. Okay, so what you hear right now is the top of the stack from this kick being played. I'm gonna show you what that looks like in the oscilloscope. Where is it? Here it is. So this is the op that sends the top of the stack to the other instrument, and you can sort of see here what that looks like. I'm going to turn it up a little and make it a little wider. All right. Can you see that, or is that too small? I'm trying to find a place here on the wall that's maybe not as dirty. Okay. So this is what this first envelope looks like. Very short attack, very short decay, or well, pretty short decay, but it looks very short here in the oscilloscope, and a very short release as well. You don't actually get to see the release at all because the decay is slow enough that it already reaches 0 before you even get a chance. And then I'm going to move this down the stack, and you can see at every point in the instrument what the current top element of the stack looks like. So the next thing I did was I created another envelope that looks like this. This has a much longer decay, and then I added an oscillator in LFO mode and created a very slow sine wave. So now we have 3 elements on the stack. We have the very fast and the not quite as fast, and then we have the sine wave. So what I'm doing now is I multiply the sine wave onto the long envelope, and that gives me this, which is, if I can amp that a little, you can see it starts. It's a sine wave that starts out with a high amplitude and ends up at 0. And then I'm adding to that first short peak. And now we're already pretty close, actually, to the envelope that's come out of the analytics process. So the only thing that's needed there is this little plateau here, and for that I'm just gonna add another envelope here. Looks like this, and just add it to the other one. So arithmetic plus, and there you have the pitch envelope that almost looks like the one in the kick synthesizer. So what do we do with that? Now I'm sending this to some later oscillators and filters. But the important thing here is that this is the pitch envelope, and we've created it from 4 compound envelopes / low frequency oscillators in Vierklang. And it's a pretty faithful representation, and it turned out to work pretty well. So the next thing was the amp envelope, and what I came up with in the kick synthesizer looked a little like this. Let's move this out of the way so you can see what's happening. This is the amp envelope for the kick that I want, and this looks like it's going to be a little easier to do than the other one. So I'm just going to quickly go through here and show you the different stages. This again here is my tool to analyze, and I'm just going to move it down the stack. So this is the first part, an envelope here. I distorted that. You can distort envelopes as well. So if you want to blow them up, or you can even filter envelopes. That gives interesting effects sometimes as well. Makes them smoother. Let me see, where are we here? I think I lost my place here. Where am I? Oh, here's my store. Going down, and I made a mistake here, and I'm just making it worse. Okay. Yeah, so this is the sine playing with the pitch envelope now. And now I'm creating the amp envelope. So I'm starting with this. and you can already see that this is the peak that comes in a little late. So we're not starting at full volume. We're getting to a peak a little later, and you can already see this is what this envelope does, and I'm distorting that as well. Here you can see what happens in the distortion. It's just blown up a little, and it looks like a pillow now, which is nice. Pillows are nice. So now I'm using arithmetic push here, which creates a second copy of the currently top item in the stack. So we have 2 times the same envelope on top now, and then I'm multiplied with each other. So I'm basically creating a quadratic version of it, and adding the other one. So now we are pretty close to this amp envelope. It's about right, I think. All right, so we have the pitch envelope, we have the volume envelope. Now we just need the click, and this is the thing I love about this new Vierklang version. You used to be limited to 32 slots for your operators. Now we have 64. Whoa. And I'm going to use a lot of those. Let me just quickly find again. Geez, it's really hard to see stuff from here. I'm sorry. So, whoops. This is another thing here. Let me back up quickly. So this is basically already the kick with both applied, and it already sounds like a kick. You know, it has the correct pitch curve, it has the correct amp envelope. And what I'm doing now here, this is not really relevant to this seminar, but I'm just going to quickly go into that. After this, I have a section for sidechain volume, and what I'm doing there is I'm creating a, if I can. I keep losing my position here. Okay, so I'm creating an oscillator here and using that as a volume for sidechaining. The interesting thing there is that I can send that to other channels, and I'm going to talk about this in a bit. But the oscillator here is actually quite interesting because this is using the gate mode, and the gate has a bunch of checkboxes down here, which are actually just a bit mask, and I can say this is on, this is off, and if I uncheck something here, you can see the difference in the wave up here. So I just turned these into zeros, and you can see there's a hole in there. So you can in a way make your own oscillator and use it kind of like a wavetable kind of thing. And this is good for I've used it for stuff that sounds like a choir or like a vox pad, which is a bit harder to do with you know the regular pulse waves and sine waves and triangles. All right, but I'm not going to go into that too deep today. That's maybe another seminar. So I'm moving down through the stores that were used to do the sidechaining on other channels, and I'm now back to the kick. And now what I'm starting to do is this is the volume envelope for the click, and the click is going to be made up of noise. So I'm adding white noise, which is always fun to hear. I'm just going to let that run for a couple of minutes maybe. I'm actually creating a second version of it because I like it so much. No, but then I'm filtering it, and now the fun is all over. You can't even really hear it anymore. So it needs a bit of punch. distortion makes it louder. Oh no, it's back to really loud. Now it starts sounding like something click-like. Even better with some distortion again. And now these are added together and the volume envelope applied again. And now we have a click. So this was all maybe a bit fast, but I'm gonna make the patches available for download. Hopefully that's gonna be possible on the site. I'm looking at you, Shake. Is that gonna be possible? All right. So you can download the instruments and see for yourself exactly how it's done. This was the short version, and even that was pretty long already. So the rest of the instrument, there's still a lot to come actually, but I'm just gonna skim over it. Here is where I add the click to the kick, and now it really sounds like a kick that you can use in a track, and it's actually what I did. This is pretty much the exact kick that was used in 2014's Stroboholics Kepler that was used in the Revision 2014 8K competition, and it sounded good on the big system there. I was pretty pleased with it. All right. I've done some more filtering there to get a few of the noisy frequencies out, but it's all pretty uneventful in terms of sound design. It's just a bit of EQing using what Vierklang has available in terms of frequency changes. So yeah, that's those were some words about working backwards, and this is what the attack phase looked like in the end. And I want to close maybe with a few words on what makes a sound fat. Somebody already said, please detune, and yes, that's a big part of it. Pitch. You see here a pitch curve. You see here a sine wave, and I have two. Let me move that out of the way. I have two sine waves here, one white one, one red one, and you can see they're at different pitches because they are at different widths. So if you have these running on the same channel together, they will produce one kind of fatness, and if you have one running on the right and the other one on the left, it will be a different kind of fatness, and it will sound really good actually, just from that simple change in pitch. And there's another thing that that's cool about the new Vierklang version. It has now stereo oscillators, and the detune parameter detunes the left and the right channel in different directions, so you automatically get that for free there. And just let me quickly see if I have an example. So this is just a straight saw wave. Let me see if I can find it. Yeah, here. And now I'm going to detune it. This is a stereo operator. Don't overdo it, or you'll end up sounding like Matter at the Love Parade. But yeah, this is changing the pitch is a really good way to fatten things up. Basically, the more different things the brain things are going on at the same time, the fatter that makes it sound. And the next thing that can change from left to right channel to or even on the same channel to make things more varied is the phase. So what that means, phase is different the same wave at different starting points, so they're slightly out of phase with each other, and that creates a feeling of width if you have one playing on the left side and one on the other. And I'm gonna drag up the example I've made for that. Just a sec. So what's happening here is this is a straight phased. All oscillators are playing. I'm having 3 oscillators play at the same phase, and now I'm going to change the phase to be randomized. And I'm going to show you in a second how to do random settings in Vierklang. And that already sounds a lot more fat. And how I did it was I used a distortion. And if you put the distortion's bit crusher on 0, that creates a single value that's random from the input. So if you have a noise, there's your random value, and you set the bit crusher to 0. The first value that gets into that bit crusher, that's all that it's going to ever put out. And that's going to be different for every key press, so you have a random generator there. And what I'm using then is stores here sending that value at a certain amount to the phase of these operators, of these oscillators. So for every key press, they are going to start in another point of the wave. And the next thing that we can do is distortion and noise. If you have a distortion or any other kind of noise and it's different on the left channel than it is on the right, that's going to widen the stereo field, and that's going to make stuff sound fatter again. So let me see if I can find my example for that. What I did was I took a saw wave and added a couple of octaves there, and added some distortion that's different on the left and the right side. So this is what it sounds like now. And you can hear the distortion. And that makes it feel, spacey and fat in a word. And I think I've got one more, which is reverb and delay. And this is also used in this patch. It's pretty easy to set it up so that there are different frequencies of delay in the left and the right channel. What you do is you have a stereo signal, you add a delay line to the top part of the stack, and then you switch them around, so you have the undelayed on top and add another delay line. And that's how you get a different delay on the first and the second item on the stack. All right, so I think we're already almost out of time. So I'm just going to take a couple of questions, if any of you have them. Raise your hands if you have a question. I'm being told I have more time. I don't know. Do you have any more stamina? Can you listen to more stuff? I've got more stuff I could talk about. All right. You have a question. All right, yeah. So the question is, if I understood that correctly, you want to know how to modulate or automate in Vierklang. That's possible. That's actually the part that I just skipped because I thought I was out of time. Thinking outside the patch is using remote stores, so you can influence one channel from inside another channel, and you can use that, for example, to set up control instruments where you read the note parameter, which is the only thing that Vierklang keeps of the MIDI data that gets into there. So you have 127 different notes that you can play on the control instrument, and you can send that value to any op in any other instrument. So, for example, if you build a control instrument that reads the notes that you play and stores that note into the cutoff on the filter of another instrument, you can do a filter sweep simply by playing the notes on the keyboard, or if you input MIDI data, you can set the filter cutoff that way, or you could even do an envelope in another instrument and store that into the filter cutoff in that first channel that you want to modulate. You do lose a channel by that, yeah, but you really only need to use one channel for that, because what you can do is you set up, you read the note, and then you can send it to all kinds of things, and you don't have to use a new instrument for every new node that you need. You can, if you're using envelopes, you can even do several of them in a row and just pop them until the stack is empty and start a new stack within the same instrument. All right. I'm going to show you some instruments that I've made, just very quickly, because I've already got them here. So you've already heard this one. This is a good lead as well. It's not just a bass. And what that uses is very extensively uses stereo oscillators with different pitches. It's quite a long patch as well. And you'll notice that the first thing I do after the envelope, and it bears noting that this envelope is used internally by Vierklang to determine when to actually put out sounds. So this is why it's unchangeable. This is why it's always there. That's what Vierklang needs to determine when it actually plays anything on that channel. So, but I don't really want that right there, because what I'm doing later is I'm adding so many oscillators that I'm reaching the hard limit of stack items. And it's actually not a very high limit. I think it's just 5 or 6 items that can be on the stack before it gets full. And when the stack gets full, I don't think there are any checks in the code for that. So anything can happen. It's just unpredictable and likely to cause dropouts, crashes, high CPU usage, even higher than usual. This patch that I'm playing, 2 notes of that at the same time, 186%. CPU usage on this old machine. It's quite expensive, but on a new machine it performs okay. So yeah, what I'm doing here is I'm popping that envelope, so I have one more place in the stack free, and then I'm adding 2 stereo oscillators and adding those together and removing the top 2 again. And I'm doing this like 4 or 5 or 6 times until I have a total of, I think, 24 oscillators stacked on top of each other in 3 different octaves, and they're all detuned to each other. And some of them are using different phases, so it's all there's a variation of a lot of different things going on at the same time, and that makes it sound wide and full and just fat. Another instrument that I can show you is a bit softer than that. So this is basically the standard super saw that's been used in all kinds of electronic music. And what I'm doing there is basically I'm trying to emulate as closely as possible the JP8080, I think it was, that had the original super saw, which means there's a saw wave at a center frequency and then 6 other saws stacked around it in specific intervals with different pitch offsets. So you have the one in the center, which has the exact frequency of the node, and you have 3 on top of that in rising pitches and 3 below that in matching rising pitches to the other direction. And that's actually done with mono oscillators. I don't remember why. I think it might have been before that feature was in there. But it doesn't make it necessary to pop that first envelope. I can go through here and just add these together and never really go over that 5 here, that magic 5. This is the one where the most items are on the stack. And you'll see here I'm using that trick again, noise, distortion with bit crush RN0 to generate random values. If I don't do that, maybe I can change that to just show you the difference. If I clear this and instead use a single value, which can be done with the load parameter, this will just create a value of 0. So now the phases are not changed at all, and the difference in the sound is actually not that bad. Wow, okay. Maybe I don't need those then. Good to know. Wait, I'm gonna check and see if the difference is hearable. Oh, there's a little bit difference. It sounds a bit more aggressive, a bit more crunchy when you have the randomized phasing. All right, let's see, what else do we have? We have, oh, this is nice. This is a good bass patch where I have just added the phasing and the detuning. And what I did there was, I think I used, no, this is one where I didn't use that. But I can show you what it does. So this has a single filter right now here. But what we can do is we can duplicate that filter, and it will turn into a steeper filter. If you use the same settings for the filter and just apply it twice, that's the same as using a filter with steeper slope. So I'm just gonna make space for that and duplicate it, and we'll see how it changes the sound. Copy, paste. Oh, that's a real groaner now. Maybe a bit less resonance. Sounds very analog already, I think. Yeah, so this is the kind of stuff that you can do with Vierklang when you set your mind to it. And there's also all kinds of things with drum synthesis and so on that I didn't go into today. I didn't prepare much for that, so I can't really show you anything meaningfully. But what I can do is I can play something that I made earlier from all these patches that I showed you today. just combine them into a short loop, and I'm just going to play that, as the outro for this seminar. So thank you for coming, thank you for listening, and maybe see you next year.